Hello, everyone. Today we're going to be talking about displacement versus time motion graphing. The objectives for today are to be able to identify the displacement, velocity, and acceleration of an object through time based on a graphical model. So sometimes it's hard to describe the motion of an object just based on words, and sometimes graphs are helpful in order to see what's happening. Remember, motion is a change in position measured by distance and time. Speed tells us how fast an object moves. Velocity is a combination of speed and direction, and acceleration tells us how quickly and in what direction the velocity is changing. Distance versus time graphs. Plotting distance against time, d versus t, can tell you a lot about motion. So time is just going from the origin to the right, and the further to the right you go, the more time has elapsed. Distance is plotted on the y-axis, and the higher up the graph, the further from the starting point you are. This is also true for displacement versus time. If an object is not moving, there is just a straight horizontal line on a dt graph. It means that it's keeping the same distance through time, so it's not moving at all. If an object is moving at a constant speed, it means that it has the same increase of distance in a given time. So it's going to be a straight line. So here's one, and here's another. The first one is going to have a faster increase in time, but it's still a constant. This is a direct relationship. And the red line is also a direct relationship, but it is slower than the black line. You can also have a straight line that is straight across, horizontal. This is still a constant velocity, but again, it is not moving. So that constant velocity would be 0 meters per second or whatever the unit is. And you can also have a negative velocity. So it has turned around and it's going in the opposite direction. Here is a displacement versus time example. We're going to start here, and we are at 5 meters, and it kind of hangs out there for about a second, and it doesn't go anywhere. So its initial velocity is 0 meters per second. You can see that we have meters and we have time as seconds. And then it gets going at a constant velocity. And if we take that slope, we would be able to find out what that constant velocity is. Remember, the slope is y2 minus y1 divided by x2 minus x1. So it would be 10 minus 5 divided by 2 minus 1. So it would be 5 meters per second, and that was constant. And then it hangs out again and just sits there for about 1 second, and it stays at the 10 meter mark. And then again, it has another 5 meter per second constant velocity. And then it hangs out for a second at the 15 meter mark. And then it turns around and goes the opposite direction, but it goes pretty fast this time. It goes from 15 to 10 meters in just 1 second. So that is, 15 to 5 in just 1 second. So that is a 10 meter per second in the negative direction. So a negative 10 meters per second constant velocity. And then here it goes a little bit slower, and it's at a constant velocity for 2 seconds, and this time it's 5 meters per second again, but it stays that way for 2 seconds. And it has passed its original starting point, and it is going in the completely opposite direction. It has passed it, so it's now at the negative 5 meter mark. And it hangs out there for a second, and then it returns to its starting position at the end of 10 seconds. And that's what the total graph looks like there. And then we have a second graph that's also displacement versus time. If this was distance versus time, it wouldn't be going back to its origin necessarily. It's just talking about the distance it had traveled. But the displacement tells you the direction as well as the distance that it traveled. So here it's starting at 0 and it also ends at 0. So it does return to its origin, and it does that in 8 seconds. And it has a constant velocity to start with. And then it hangs out there at the 20-meter mark for a second. Again, constant velocity, but this time that velocity is 0. And then it goes from 3 at the time 3 and 20 meters, it goes up to 40. So that's 20 meters in 1 second. So a 20 meter per second velocity, constant velocity. And then here it goes in the negative direction. It's turning around and going down. And that's in 4 seconds. And that slope is 10 meters per second. If we say 40 minus 30 in that 1 second interval. So that is a 10 meter per second in the negative direction. So minus 10 meters per second squared for the velocity. And we just get that from the slope. So here are two objects that are moving at the same time. But if you look at their slope, the one with the dashed red line, that one is moving at a faster speed because it got there in a faster amount of time. It moved the same distance. So this should be the same distance across. It'd be easier with it marked, but this should be about the same distance. And it took the red line much less time to get there than it took the blue line. So a steeper line indicates a larger distance moved in a given time or a higher speed. And because both lines are straight, both speeds were constant. Here's acceleration for the distance versus time graph. On a distance versus time graph, acceleration, it looks curved. That's how you always identify acceleration on a distance versus time or displacement versus time graph. And because the speed is increasing over time, it is acceleration. So because the object is covering more distance in every tick of time, it is accelerating more and more distance. So here is a quick set of practice problems. Which of the graphs shows that one of the runners started 10 yards further ahead of the other? So if you look, here's 10 meters per second, 10 meters. Well, if I get the units right, 10 yards. These are starting at the same place. This one here is starting at the same place again because it's at 0 yards. And this one, it goes from 0. One starts at 0 and one starts at 20. So these are 20 yards apart. And this one is 0 and 10. And so this one is 10 yards further apart. So that would be the correct answer here is A. And then this last one, in which of the graphs are both runners moving at the same speed? So you're looking for something that has the same slope. So which of these graphs has the same slope? And that would be this one here, which is choice C. All right, that's all I have for you. Thanks.